This is the video tutorial created by our group under the unit Programming Language Design Concepts. The topic for this tutorial is threads. We will be introducing you to threads using the language Java. Later in the tutorial, we will be covering threads from other language such as C#, C++, etc. Under this tutorial, the contents would be an introduction to threads. Under that, what threads are, why we use threads. Then we'll come to threads in Java, where introduction would cover a general understanding or general concepts of threads, and under the second topic it will be about threads in Java, and then an introduction to Java virtual machine. After that, we'll go into little bit detail of each topic under each topic of threads in Java, starting with how to create threads, instantiating a thread, starting a thread, multiple threads, that is the Java language allows us to create more than a single thread to run by a single program. So we will be taking you all through that. Then the thread scheduler, which comes under the JVM, which handles the life cycle of a thread, thread states, and thread priorities. Introduction. What are threads? A thread is an independent sequence of execution of a program code in a process. Or in other words, a thread is an independent sequence or a section of coding which executes a part of the program individually. Also, a thread can be assigned to execute a program divided into subsections. A thread also can be known as a lightweight process and is the basic unit of CPU utilization, or which means a thread is very small in size, which needs a very limited amount of memory to store all the information with regard to the execution of thread plus all the data segments, and each thread can be assigned to be executed in the CPU individually. A single program in execution or a single process in execution can have more than one thread. A thread created by one process, or the memory segment allocated to a thread that is created by one process, won't be visible to another thread created by a different process. Threads are allocated to the CPU to perform its operations as in general, which means a thread will be allocated the CPU to execute or to perform the functions that is meant to be executed by the thread. On multiprocessor systems, each thread will be allocated a different CPU so that threads could be run parallel, plus making maximum use of the multiprocessor architecture and also making the program more convenient and faster. A memory segment of a process is shared by a thread. The same memory location or the same memory segment which a process is allocated by the operating system will be subdivided to maintain the memory needed to execute the process. Each memory segment, when we consider as a multi-thread architecture, what happens is each thread's memory segment acts as the thread's own memory. Why threads? Threads, when you consider our processes, are very much quicker to response. That is, threads provide output or results way quicker than processes. Threads also share resources like memory segments, where it helps in a major way for inter-process communication. Threads are also quicker to create, delete and handle than processes. Threads make the maximum use of the multiprocessor architecture because in a multi-thread program, each thread can be assigned to a different CPU or different processor to get the required output very much faster than in general. Now we'll take a look at threads in Java. Threads can be created in Java using two methods. One is either you can extend the java.lang.thread, the thread class in the Java lang package, or else you can implement the runnable interface which is also in java.lang package. Threads in Java, you can say it's an instance of an object like any other object in Java. The thread object also has variables and methods and lives and dies on the heap. But it is also a thread of execution, which means it's an individual process or a lightweight process that has its own call stack.